Math 2A. Today's Monday the 4th. And this lesson factoring polynomials. Okay, in Edmentum, this is going to correspond to what they call part 2. So in Edmentum, I'm going to put that here just in case, so it'll be easy for you to know what it goes with. In Edmentum, it's called factoring polynomials part 2. I'm going to name this lesson factoring polynomials when a is not equal to 1, the difference of squares, and perfect square. This is what we'll be doing in today's lesson. So we're still factoring polynomials, but we have to look at these 3 different cases that we haven't done yet. So we're going to start when a is not 1. So far, we've only seen cases when a is 1. And then there's these 2 special cases. The first one called difference of squares, and then the second one's called the perfect square. And these are actually shortcuts that we can use sometimes when the problem, the polynomial that we're trying to factor, applies to that. It doesn't always, but sometimes it does, and then we can use one of these 2 special case shortcuts. So that's what our plan is today. We're still factoring polynomials. Just a reminder that our homework so far, we've had some questions to do on paper. I will later send out a list through Remind with a picture of those problems if you haven't done them yet. I think only maybe 2 people have done them so far and sent me pictures of your 6 questions for Unit 2 that we're in now. And you know what? It wasn't even 6 questions. It was shorter. It was like 2, I think, that we did factoring for. And then we did do the mastery test. So just a reminder, don't fall back on your homework, or fall behind rather. And you know what? I don't have a list of the paper questions yet. So I need to do that this afternoon, and I'll send it out on Remind. So we did some paper questions last week. Paper questions on factoring, and then we did do mastery test of factoring polynomials. Part 1. And today our goal is to be able to do part 2. Factoring, sorry, I know that's hard to read. Factoring polys, part 2. Okay, I'm talking a lot. Any questions so far? Any issues reading what I've written so far?
Is this the homework throughout the whole thing?
A whole unit 2 so far, yes.
So we only have 2 master tests that we're supposed to do?
No, I think we also did the multiplying polynomials, but the truth is I need to double check what I've assigned you guys.
Okay.
It has been at the end of each video, so at the end of each lesson. So if you're here with me each day last week, basically everything we did last week is homework. But truth is, I didn't go over that list myself this morning, so I should have done that. But anyways, in the meantime, I know we did these, and if you haven't done these yet, catch up on those. The Thursday was the mastery test for factoring polynomials, part 1. This afternoon, I'm going to make a list of everything we've done so far for homeworks to send you that, so you'll have a nice list and know what you're supposed to have done. Okay, so I need to catch up on that, and I'll send it to you all who are on Remind this afternoon. Okay, no other questions? Let's get going. Okay, so let's start with when a is not equal to 1. Now remember, whenever we're dealing with our polynomials and we're trying to factor them, they're going to be in standard form like this. Ax squared plus bx plus c. And this is how we did our 6 steps to factor, right? We had to identify what is a, b, and c. So all last week when we were doing our factoring, a was always 1 because our problems were always something like this. I'm going to go back. Our problems always looked like this. X squared plus, for example, 5x plus 20, something like that. A was 1. But now we're going to have examples when a is not 1. Example for a not equal to 1. Let's start with this. 5x squared minus 11x minus 12. So the good news is, for most of you following along with me last week, who I had the chance to work with and hear some feedback on, who were following those steps, or at least trying to, you were identifying A, B, and C, and then making our lists of numbers that multiply to whatever A times C is. So in last week's examples, it was always just C, because when A is 1, 1 times C is just C. But now we're going to have to start making our list multiplying the A number, which is 5 in this case, and then the C number, which is negative 12 in this case. So let's start that now. Let's factor 5x squared minus 11x minus 12. The good news is all we got to do is follow our steps. But we have to now be aware, if a is not 1, make sure to multiply a times c. So let's start that now. Same problem. 5x squared minus 11x minus 12. So make your list multiplies to a times c, which is 5 times negative 12. So negative 60. Let me double check. Yes. And then we want to check that to see which pair of numbers adds to b, which is negative 11. So we're going to have, looks like one of our numbers will be negative this time because we have to have a negative to make that negative 60. And then when we add them, they should add up to negative 11. So start by just doing the list of positives to see which ones go to 60. So 1 times 60, 2 times 30, 3 times 20. Try doing 4. I think that's 15. 4 times 15. 5 times 12. That's how we got to 60 in the first place. Notice that when you're making your list of multiples, and if you start at 1 and then move up to higher numbers like 1, 2, 3, 4, 5, then the other numbers that are in the matches are getting smaller, 60, 30, 20, 15, 12, and they're kind of meeting in the middle or close to each other in the middle. 6 times 10, and that's probably it. 7 doesn't work, and 8 doesn't work, and 9 doesn't work. So that's it. After this, our list would just repeat. It would be 10 times 6 and 12 times 5. So we're just going to stop there. Now look through the list and see which set of numbers has a difference of 11, because that's what we want it to add up to, is negative 11. So the difference of 1 and 60, that's huge. That's 59, so that's too big. 2 and 30, it's too big. 3 and 20 is 17. 4 and 15 is probably our winner because 15 minus 4 is 11. So now just double check which one is positive, which one's negative. 4 minus 15 and negative 4 plus 15. So 4 minus 15 is negative 11. That's the one we want. negative 4 plus 15 is positive 11. So we want to make our 15 the negative, and our 4 will be positive. And I'm going to circle those so I don't forget about them. Now, remember, what do we do when we've made this list and we found the right mix, configuration of numbers? We split up B. So I'm going to go back to my actual problem here, and we need to write it as the negative 11x, but split up with 4x, negative 15x. Okay, now last week when we did this, we had some good discussions about, does it matter which order we write our x numbers when we split them up? So for instance, I wrote 4x minus 15x right in the middle. Now, it doesn't actually matter which way we split this up, but it can make it a little more confusing or maybe a little less confusing depending on how we choose to. So at this point in our Math 2 factoring game, we want to start thinking about thinking forward and asking, can I write this in a better way to make it easier on myself? So look at how I've written it right now. Right now, I would want to factor the first two terms and then the last two terms together. If we factor it this way, it doesn't look like we can really pull anything out of the first two terms except for x. But notice that the other x number was negative 15, right? 15 and 5, we know 15 and 5, I could divide out 5 from each of those. So maybe in this case, it'd be better to rewrite it, swapping our 15 and our 4x. We should change places here because 15 and 5 go together better than 5 and 4 do. And notice also if we switch it, then the 4x and the 12 will be together, and I could divide 4 out of each of those. So it does work out a little nicer if we switch the order in this case. Now, it doesn't, if you didn't notice that and you didn't switch them, it should still give you the same answer at the end. But it might not be as like easy to see. So just remember, it's okay to write it in either order and do it in the order that's best for you that we can divide out the most. So I'm going to switch them now. I'm going to just rewrite it again, moving my 15x and my 4x. Now remember, if one of those is negative, like our 15, it stays negative when you move it. That negative sign is part of its identity, just like the positive is part of 4's identity. Okay, now we're going to continue with our steps and factor the first two and the last two. So we can pull out 5x from the first set, 15x, or I should say negative 15x, divided by 5x. If you can't do that in your head, I want you to do it off to the side on paper and just straight up divide it. So negative 15x divided by 5x, and see what's left over. Negative 3, and the x's cancel, so it's x minus 3. And I'm hoping to get x minus 3 when I divide out 4 from the other set. So divide 4. Yep, because 12 divided by 4 is 3, so x minus 3. And we get our final answer. 5x plus 4 times x minus 3. Remember, when we do the final factoring, we're kind of just pulling out the parentheses. And what's left is 5x plus 4, so they get their own parentheses below. That's the end of that one. Any questions or concerns so far? So what's different when a is not equal to 1? All that's really different is that when you start your list at the very beginning, make sure to multiply the a number to the c number, 5, negative 12 in this case. And then after that, we just proceed as normal. And then when we're factoring at the end, there'll be something more than just x to pull out. Last week, it was only x we could divide out from the first two numbers. But now there'll be some number that can divide out as well. This time it was 5x. Okay, let's try another one. So example 2, factor 4x squared plus 8x minus 60. So step 1 should be to multiply a times c and then find the list of all numbers that multiply to that. Now this is kind of a different scenario because check this out with me before you get started on your list. Look at a, b, and c this time. Notice that they're all even numbers. Not only that, but not only are they all even numbers, but I think we could divide each one by 4, not just divided by 2, but by 4. So sometimes we'll have a problem like this, a polynomial like this, where all 3 of the coefficients and the negative 60 constant are divisible by some number. So we can start actually by factoring out the highest number that can be divided by all these, the GCF. So in this case, start by dividing everything by 4 or factoring out everything by 4. So I'm going to show it with some big brackets. You could use parentheses. So what's happening is we're going to divide out or factor out 4 from everything before we even start this mess. And then we'll have smaller numbers that we'll have to deal with for actual polynomial. Let's see, 60 divided by 4 is 15. So negative 15. And now this is a much more appealing polynomial to factor than 4 times negative 60. Now, check it out. Now it's just our new a, b, and c is 1, 2, and negative 15. However, the whole thing is still being multiplied by that 4 on the outside. So that's going to be part of our final answer at the end. So now let's start our list. So multiplies to negative 15, adds to plus 2. All right, so 1 times 15, 2 times nothing, that doesn't work, 3 times 5, and that'll be it. They have to add to a positive 2, so it looks like it's going to be negative 3 plus 5. That adds up to 2. So we want negative 3, positive 5. So we do our splitting, rewriting. Just don't forget that we started with that factoring out of 4, so it's kind of hanging out on the left until the end of the problem. Okay, any questions right now before I continue? Please. About the 4, about the lists, about anything at all. Okay. Well, then we just continue as normal. Factor the first 2 and the last 2. We can factor out x, and we're left with x minus 3. We can factor out 5, and we're left with x minus 3. And just notice this is all happening inside those brackets we made. The brackets are acting just like parentheses. It's just grouping. We pulled out that 4 initially, so we're working only inside the brackets for the rest of the problem. And then we can factor out our x minus 3. So we've got x plus 5 times x minus 3. And now that we're done factoring and everything's just being multiplied, 4 times the brackets times x plus 5 times x minus 3, now I'm going to drop those big brackets like this and just show everything as a string of multiplication. 4 times x plus 5 times x minus 3. And that's our final answer. So that 4 times is important because it is there in the math, right? It's there in the polynomial. And we have to show it at the end here that we're keeping track of it, that we haven't thrown it away or forgotten about it. No questions, comments, concerns? Okay.
Josiah, that was the answer for the
Yeah.
factor?
Yeah, this is the answer at the bottom right here.
Okay.
Quick side note, if we hadn't started this problem by factoring out the 4, you'll still get, well, we should still get the same answer at the very end.
Mhm.
But it'll just look different. And honestly, the list we make would be crazier because let's look again at the very beginning, 4x squared plus 8x minus 60. If I hadn't factored out that 4 to start with, our a times c would be negative 240. So that means we'd have to make a list of all the numbers that multiply to 240, which I'm assuming would be harder to keep track of. For me, it would be, because then it'd be a longer list here. And at the end, we should still find the same answer, but it will just be a lot more work. So even though this is kind of weird and different to start our problem this way, it is going to make it easier in the long run. All right, let's try. We've only done 2 examples. Let's try one more like this, and then we want to look at the difference of squares and the perfect square special cases. Here's number 3 for today. Factor 6x squared minus 11x plus 4. Notice that a is not 1, a is 6. Now, this time, see if we can divide out 2 or 3 or 6, right? Because I'm looking at a and I'm like comparing it to example 2. Like, can I pull anything out before we start to make this easier? This time, no, we can't, because we'd have to be able to divide it out of all terms, all 3 terms. I could divide out 2 from 6 and from 4, but I can't do that at 11, at negative 11. So we're kind of stuck in this example. We have to continue without factoring to begin, like we did last time. So we make our lists that multiply to 6 times 4, 24, and adds to negative 11. One times 24, 2 times 12, 3 times 8, 4 times 6, and that's the end of our list. So now you look at those like the list of multiplications, and see which one has a space between them, a difference of 11. So just subtract, like the bigger minus the smaller. 24 minus 1, that's 23, too big. 12 minus 2, that's 10. 8 plus or minus 3, right? Because I guess I should have said we could add them or we could subtract them. We want to find which one, when you mix them together through adding, makes an 11 or actually a negative 11. So since 3 plus 8 is positive 11, that seems like we're on the right track. How can I make it a negative 11 and still have them multiply to make a positive 24? Well, they both have to be negative. Remember, whenever B or C is negative, that's a clue that at least one of our numbers is negative. So in this case, they're both negative, and negative times a negative makes a positive 24. And if they're added, it makes a negative 11, like we want. So negative 3, negative 8. Now we just do our splitting up like normal. So back to the actual problem in the middle. And remember what I said about being strategic about how we write it this time. So since our numbers are 3x and 8x, negative 3x, negative 8x, match those up in a way that you could divide something out from each set, right? So if I choose the 8 next, this way, okay, the first set's okay. I could divide out 2 from 6 and 8. I could divide out x. But from the second set, it looks confusing. I've got 3 and 4. Can't really divide anything. So I'm actually going to write it again, switching my 2x numbers. This is a better setup for me because And now I've got the 8 and the 4 matched up and the 6 and the 3 matched up. We're going to factor each set now. So on the left side, the first set, we'll pull out 3x. Okay, now I'm going to show this work factoring it out. So we've got 6x squared, and I'm pulling out 3x. So divide it on the left side as your scratch paper. 6 over 3 is 2, and then x squared over x to the first would just be 2x. So we're left with a 2x, and then if we're dividing negative 3x by 3x, we should be left with negative 1. So 2x minus 1. Now for the second set. 8x plus 4, negative 8x plus 4. So notice that the signs are mixed up, right? It's negative 8x plus 4. And I want that negative to be with the 4. So we're going to divide out negative something. That's our clue that we're dividing out negative and not just the whole positive number. This will switch the signs. So I want this to be 2x minus 1. So that means I need to be pulling out 4 to make that into minus 1. Let's see if that works. So scratch paper on the left side again. Negative 8x divided by negative 4. Okay. That'll be positive because negative over negative. And 8 over 4 is 2. And the x is still there. So it should be a 2x right here. And then a 4 divided by negative 4 is minus 1. So we did it right. We've got our 2 matching parentheses. And now we're going to pull out the parentheses, factor the parentheses. So we're left with 3x minus 4 and 2x minus 1. And we're done. There's our answer. I'll circle it or box it. That's example 3. Any other questions right now? Concerns? Okay. So these examples are just like last week, except if we're starting with a number for A that's not 1, like 6 was in this problem. Going back, we had 4 and then 5. So the last 3 examples. Just make sure when you start that we're multiplying the A times the C. Because we didn't do that last week because A was always 1, so we didn't really notice it, even though we were multiplying it. But 1 times C didn't really change it. And then also, like example 2, maybe we could factor out some number coefficient from all those before we start. Always do that if you can, because it'll make it an easier journey and less math to do to find your answer. So in like example 2, we started by factoring out 4 from everything. So check to see if you can do that before you even start. Okay, now I want to talk about a special case called the difference of squares. So what this is a special case for factoring a polynomial. Think about it as our special case for factoring. So let's look at the name, difference of squares. Difference means subtraction. And squares, what we're referring to are numbers that are being squared. Numbers being squared. And you remember what squared means. It's a number times itself. So this means subtraction of numbers being squared. So let's see what that might look like. This will be example 4 for us today. So x to the second power minus 16. Now this is an example of a difference of squares. Difference because subtraction. And notice that both terms here, x squared, well, that shows us it's being squared. So this is obviously a square number. I'm just going to say the number sign if that's okay. Square number. And then 16, double check that is that a square number? Sure. That's 4 times 4, or 4 squared. A square number. So what we're looking for is if you're given a problem that looks like x squared minus 16, how it started before I started making notes on it, check to see, okay, is this minus? Yeah. Is a difference, a minus sign right in the middle? Are both of these numbers square numbers, like something to the second power? Sure. X to the second power is square number. And then 16 is as well, because you could write it as 4 to the second power. So you're kind of going through and asking yourself, does it meet the qualifications? Does it meet like the requirements? Sure, it does. So in this case, the difference of squares is fast and easy to factor. And I'm going to go to a new screen, but we're going to finish this example. So continuing example 4, we've checked to see that this is a difference of squares, and it is. So then you ask yourself, what is the square of the constant 16? I'm sorry, the square root. What is the square root of the constant 16? It's 4. We talked about that already. So we can factor it like this. X plus 4 times x minus 4. So if we have a difference of squares, then it's always going to turn into x plus the square root times x minus the square root of whatever the c number was that we had above. Now, I'll show you this generally speaking, like how it would look in a math book, how it would apply to every different problem. So let's look at that really quick. This is like the generic generalized rule. So if we have something like this, little a to the second power minus little b to the second power, this is our x squared minus 4 squared. So our 16 is, if you wrote that as a number being squared, it would be 4 squared. Then this is equal to, every time, a plus b times a minus b. And that's why I wrote my example, x plus 4, x minus 4. So really quick, before we do any more of these difference of squares, let's just see how our x plus 4, x minus 4 turned into that short polynomial, that binomial that we started with. So let's just kind of work backwards and see where that came from. X plus 4 times x minus 4. And if you multiply this out like we started in our unit, we get x squared minus 4x. And now do the plus 4 has to be multiplied to everything. So plus 4x minus 16. So see all those multiplications below there. There are x squared, that's there. Minus 4x plus 4x cancel out completely. It's like saying plus 4 minus 4 together, right? So it goes to 0x. So it goes away. And what's left? X to the second power minus 16. And then, of course, factoring is working backwards. So if we started with the polynomial, the binomial at the bottom, and worked backwards, we should be able to get x plus 4x minus 4. Now, here's another quick thing I want to say. If you don't remember the shortcut that I'm teaching you today, then you can still factor x squared to the x squared minus 16 using our method, our 6 steps, and it'll still work. Um, x squared minus 16, a, our big A, right, is 1. There's no b there, so we say that's 0, and our c is negative 16. So if you make your lists, we get multiplies to negative 16, and it's got to add to 0, add to b, right, which is 0. So we're looking for numbers that multiply to 16, but when you add them together, they've got to make a 0. And since our c this time is negative 16, that means one of our numbers is negative as well. So it's like 1 plus 16 or 1 minus, negative 1 plus 16 or 1 minus 16. You have to check them all. And the only one that'll work is 4 minus 4. That's the only set that makes 0 when you add them together. So then we set it up. We're factoring it the long way here. This is not using the shortcut. Factor out 4. And then you can factor out the parentheses. So we end with x plus 4 times x minus 4. So there's our answer factoring it, but this is like doing it the old-fashioned way, doing it with the method I taught you last week. We want to be able to use our shortcut and save some time whenever we can. No questions right now? Let's look at one more difference of squares problem. Example 5. Factor this polynomial x to the second power minus 25. So first thing you should ask yourself is this a difference of squares? Yeah, it is. It's a subtraction, so that means it's a difference. And x squared is a square number, obviously. 25, is that a square number? Yeah. If you don't remember, try it out on your calculator. See if just do 4 squared, that's 16. 5 squared, boom, 25. So we can factor this right now using our shortcut. X plus 5 times x minus 5. Remember, the plus and minus number that we're putting into our parentheses multiply together to make 25. So it wouldn't be x plus 25, x minus 25. Double check your work before you put it in Inventum or turn it into me. 25 times 25 is huge. That's even bigger. They multiply together to make that starting C number. Any questions, concerns? Please. Okay, so that was the difference of squares. And there's one more special case I want to show you today. It's called the perfect square. This one's a little different, but it obviously involves squares like the last one did. So there's a shortcut for this as well. Example 6. Let's do this. X to the second power plus 20x plus 100. So this time, it looks more like a normal polynomial, right? It's got A, B, and C written there. The B's there, not like the last two examples. So if you notice, while you're doing one of these problems, that C is a square. So I'm going to put it down here. If C is a square number, and this time it is, 10 squared is 100. And then also if b is the sum of the square root of c plus the square root of c. If b is the sum of square root of c plus square root of c. Let's double check that. What's the square root of c here? It's 10. 10 plus 10 is 20. So I mean the coefficient. So don't worry about the x right now, just the number, just the coefficient 20. And this checks out. Then our shortcut is x plus 10 squared. Means the whole parentheses is being squared. So it's x plus 10 times x plus 10. So if it meets these two requirements here in the middle, then we can jump straight from the polynomial at the top down to this factored form at the bottom. X plus 10 squared, the whole parentheses. And again, if you forget about the shortcut I'm teaching you, and you just factor this the normal way, it'll still work. We'd make our list of things that multiply to 1 times 100, 100, and then find the set that adds up to make a 20 in the middle. We split it up, factor away like normal. So you can still use our method, but these are shortcuts meant to make it faster for you. Let's look at x plus 10 squared. We'll multiply that out and see how the polynomial came from that in the beginning. So just kind of checking our work to see where that shortcut rule is coming from. So x plus 10 squared. So what does that mean? That means the parentheses times itself. Multiply it out. X to the second plus 10x plus 10x plus 100. So there's the 100 that's emerged, and then 10x plus 10x makes 20x. So that's where all the parts came from. And if you kind of look at the bottom and work your way back upwards, you can see where the different parts join together, the 10x and the 10x. And 10 is the square root of 100. So that's why we look for that when we're using the shortcut rule. Let's look at another example like this, and then we've got a little bit of time to start the mastery test together. So example 7. Factor x to the second power minus 16x plus 64. So, lost somebody. So check to see that the C number is a perfect square number. Is C a perfect square? Yeah, it is. It's 8 squared. Is 64 a perfect square? Yep. 8 squared. Then the square root of 64, we've found it already. It's 8, right? So can I write 16 or negative 16 as 8 plus 8? Yes. But we don't want positive 16, right? We want negative. So can I change my 8s to make that work? Yes, I can. I can make them both negative. So negative 8 minus 8 is negative 16. That's what we want. And if I multiply those together, does it make a positive 64? It does. Negative times negative is positive. So our answer is x minus 8 squared. I'm going to check roll here. I know I missed somebody who's already lost the connection or left. Homework today is to do mastery test called Factoring Polynomials Part 2. Factoring Polynomials Part 2. Darn it, I wonder who that was. Now, this afternoon, I'll send out a message with like all the different homework assignments because I think we've done the other mastery tests as well. And I think I had more than one paper assignment, but I don't remember now. So I'm going to figure out which homeworks I assigned, send out that list to everybody so you can get caught up today and tomorrow. We're actually almost done with this unit already. We could finish it this week, maybe Wednesday, and take our test. So I was thinking we could tomorrow review everything from unit 2 and then take our test on Wednesday and have in another unit of math already. But in order for the unit to count, you got to have all the assignments done. So it's time to start getting caught up on those if you haven't already. So I'll send out a list this afternoon. So look for that. And if you want to ask me any questions later, feel free to text me or email me. Any other questions right now? No questions. Okay. Can I see people's notes for today? Just to make sure that you have them, and we're going to mark you down for participation.
Hey, Josiah, I have to wait for your video. I'm gonna catch up.
Okay, Jayla, thanks for letting me know. Aaron,
Yeah.
thank you, Aaron. I see your notes. Aaron, where are you? Right there. Okay, Braden. Oh, you're not. I'm sorry, Delaney. The name's Delaney. I see that. Thank you, and Leja. Thank you both. Now I see Braden's. Thanks, Braden. Sorry about the mix-up. And Manaya, got you.
If you saw our notes, can we go to our other class?
You surely can, Manaya. I'm going to release you all into the wild. Have a great Monday.
You too.
Make sure to do your mastery test tonight. And tomorrow's Tuesday, so I'll be. Oh, you know what? Actually, I won't be on tomorrow afternoon because I've got a meeting. So I'm not going to be able to do an extra math meeting tomorrow. But just text me and we can figure out a time and go over stuff if you want to. Okay, individually. And
Josiah, do you know if Jules is in the center? I don't think
she's not. I don't know all the details, but I know it's a personal thing, and I think she's going to
Yeah.
be gone this week and next week. So,
Yeah.
Okay. Thank you.
and I don't think there's even a class for you to go to except for her, except for maybe she set something up ahead of time, like videos or something like that. I'm not sure.
Okay.
I don't think back October 8th.
Right. Okay. I thought so. Thank you.
Yeah, I know she's supposed to be gone for 2 weeks, but I don't know if she set up a class or anything. I know we're supposed to wait because for her to come back so we could start unit 2 and 3.
Yeah, I think it was like a finish